Hello, friends. Today we are going to see about exploratory data analysis, in short called as EDA, and its introduction. Let us get into that. Yes, what is an EDA? It is an approach to analyze and understand the data sets through visualizations, summary statistics, and other techniques so that we can make a formal modeling or assumptions. What are the primary goal of EDA? The primary goal of EDA is to gain insights into the data, what we get through the data, what we assess through the data, so that how do we take decisions from the insights of data. Okay. What are the primary goals of EDA? Is to detect the patterns, spot anomalies, and test hypothesis. What is detecting patterns? Yes, detecting patterns refers to the process of identifying regularities, trends, or relationships within data. Yes. Give an example for that. By studying the order in which items are frequently purchased, we may find that the customer tend to first buy a PC, followed by a digital camera, and then a memory card. This example shows the typical buying pattern of a customer. That pattern may be anything: buying pattern, studying pattern, movie pattern, like that. The pattern may be anything. Therefore, EDA can be used to detect any pattern or trends. Okay. Then what is anomalies? Spotting anomalies. Anomalies actually refer to the data points or patterns that deviate significantly from the expected or normal behavior within a data set. The unusual observation in a data set is called as anomalies, exceptions, outliers. Okay. We can see one example for that. Yes, example one. The scenario is a factory uses a sensor to monitor the temperature of a machine with normal readings ranging from 50 degrees Celsius to 75 degrees Celsius. What is the anomaly? One of the sensors, that is error. What is the error there? One of the sensors reports a temperature of 150 degrees Celsius, which is far outside the expected range. Actually, it should report between 50 to 75 degrees Celsius, but it is displaying as 150, which is an error. That means, what is the anomaly causes? Because of the sensor malfunction, it is displaying, the sensor is displaying like that. Therefore, the anomaly is sensor malfunction. Therefore, we can spot anomalies using EDA, exploratory data analysis. Then we go to the example 2. Yes, what is example 2 in spotting anomalies? The scenario is a bank monitors credit card transaction to detect fraudulent activities. Most transactions are within typical spending rates such as $20 to $200. What is the anomaly? A customer who normally spends between $50 and $100 suddenly makes a transaction for $10,000 in a foreign country. That too in a foreign country. And what is the error here? The large amount is unusual, that too in unusual geographical location, deviates significantly from the customer's usual spending pattern, triggering an alert for possible fraud activity. Therefore, to identifying the fraudulent activity, also we can use the anomaly, spotting anomalies. And for that purpose, we need EDA, exploratory data analysis. Fine. What is the third one? Test hypothesis. What is the hypothesis actually? It's a proposed explanation or assumption about a phenomenon. Assumption or explanation about a phenomenon or a relationship between variables that can be tested through observation, experiment, or analysis. Through observation, experiment, or analysis, we are justifying an explanation or assumption. That's it. Okay. You can see the example. So, what is the problem? A company sells a new type of energy efficient light bulb and claims that will last for on average 10,000 hours. The company is claiming as on average a light bulb will go for 10,000 hours. But a consumer group believes that the bulb lasts only for less than 10,000 hours. How did they conclude that? By using the hypothesis testing to test the validity of the company's claim. By doing assessing the validity of the company's claim using the hypothesis testing, the consumer claims that It does not go for 10,000 hours and it will be less than the stated 10,000 hours. This is called hypothesis, test hypothesis. Okay, what do we see here? Actually, what is the primary goal of EDA? Rating the patterns, buying pattern, movie recommendation pattern, likewise, and then spot anomalies, finding the error, abnormal behavior, to find the fraudulent activity, to find the malfunction of a sensor, likewise. And then testing hypothesis, where finding the assumption or explanation is right or wrong by using the hypothesis testing. Why EDA is important? Why should we use EDA in data analysis and data science project? What it does, it helps us to understand the structure of the data, also identifies the relationship between variables. Suppose I have two variables or called advertisement and sales. Yes, definitely there is a relationship between the advertisement and sales, advertisement and marketing, cost and sales, likewise. And third point is detect outliers or anomalies that might skew the result. Yes, detecting the outliers and abnormal value or exceptional value or anomalies. We should find that so that it should not affect the output. Formulate hypothesis for further analysis. Yes, we will spot the anomalies. Okay, after that, we'll formulate the hypothesis for the further analysis. And the last step is prepare the data for more advanced techniques like statistical modeling or machine learning. After that, after preparing the data through EDA, the last step is statistical modeling or machine learning modeling. What happens without EDA? What happens to the data set and its insight? When we are not using EDA, what are the disadvantages we are going to meet? We might miss critical patterns or make incorrect assumptions that leads to poor conclusions or models. It is a foundation for effective decision making and helps data analysts avoid common pitfalls in the data analysis. We might miss the critical patterns. We'll go with the incorrect assumptions, and if the assumption itself is incorrect, then the output will be definitely not be correct. It will be a wrong output. Okay. Now, what are the real world examples? Where do EDA apply? What are the applications of EDA? Yes, sports, professional sports. Yes, why where is EDA is applied in sports? Using EDA, we can search the most successful players and teams as well. We can also discover the variables that contribute to a team's wins and losses. What are the variables? What are the factors that affect the team's win or losses? It may be cricket, it may be a badminton, whatever sport it may be. In addition, it is also a helpful tool for deciding which players or team should be selected for a company to endorse. Suppose an company is endorsing player X, they may see the history of the player X, so that it will be a better beneficiary to take that concerned person or some other else they can take for that. For that purpose, EDA is doing automatically rather than doing manually. It will be more accurate than doing it manually. Okay. History. What is EDA's application in history can create new data about the past events. Based upon the past events, it can be giving the new data about the past events. Data can be collected from sources such as archaeological digs, digitized photos, and text. It is possible for data analysts to have more robust understanding of the past events based upon the archaeological images, archaeological sculptures, which type the sculpture belong to which era. Likewise, they can identify. Therefore, analysts will have a more robust understanding of the past events that have remained a mystery for a millennia. By the past history also, we can find the solution to a mystery using EDA. Then comes the healthcare, which is a vital role of EDA. It's helpful for spotting natural patterns embedded in large stores of medical data. Okay. The medical data will be in the form of electronic medical record, that is EMR, which is collected in healthcare networks, healthcare departments, and hospitals. It will be stored. From that, when we apply the EDA techniques, it is possible to gain important insights into the progression of chronic diseases such as kidney disease. Whether we can get the important insights from the electronic medical record so that we can take a decision what are all the factors that are affecting a chronic disease such as kidney disease. Not only for kidney disease, for most many diseases, I can predict what are the significant features based upon the EDA. You will be getting the statistical information about that particular disease. Then what else? Else marketing. Yes. It sheds insights into various purchasing circumstances. Why customers are no longer buying a product or why a particular campaign is successful. By understanding the context surrounding those variables, EDA provides analysts with a strategy for future action. Why that particular product is not sold, although it has impactful or it's a needed product. What is the real impact or why it was not selling? Same why that particular campaign or advertisement is very successful. Likewise, it will reveal the insights, hidden insights to the customers. And, and next comes the retail. EDA can be used by business managers to spot weak areas in a store or a franchise in order to suggest areas that can be targeted for increased revenue. Yes, I'm having a franchise, but that franchise is not going well. In which area I can open the franchise so that I can, or at all the things I should do for that franchise so that I can improve my revenue. Everything comes from the past history. From the collecting data, everything comes from the data collection, proper data collection. And fraud detection. EDA data mining techniques are used to identify fraudulent activity by using the spot anomalies. We can use the spot anomalies technique to find the fraudulent activity. Then it also applied in the food industry. Yes. How it was? Yes, we are getting the recommendation. We are getting the reviews, which food, which type, what we like, everything we can get through EDA. Yes, pertaining to where can find that best overall restaurant in that particular area, the most popular dining option by that cuisine type, food establishment that meets certain dietary restrictions. Based upon our dietary restrictions, we can select as well as the most affordable local dining options. Recommendation. Majorly, we can tell in one word recommendation. It may be movie recommendation, it may be a restaurant recommendation, it may be a hotel recommendation. It may be textbook recommendation. It may be any recommendation through online we made. Everything comes from the EDA. They have applied the EDA concept. Okay. Then we are moving on to the next topic called key components of EDA. What are the components of EDA? Univariate analysis, bivariate analysis, multivariate analysis, missing data handling, outlier detection, data transformation, and future engineering. These are the key components of EDA. We are going to see one by one. What is univariate analysis? You know what is a data? Data is an information. Process data is an information. What is a data set? Collection of data. It will be in rows and columns format. For example, it will be an CSV file, for example. We'll be having it as a row and a column format. Okay. What is univariate analysis? Focuses on analyzing a single variable at a time. For example, I'm going to analyze my score of an exam. Score a single variable, you are going to analyze. What are things you can do analysis in a single variable? We can do the summary statistics. Yes, what are summary statistics? Mean, average value, median, the central value, mode, the frequency, number of frequency of the particular value, there is variance, etc. Frequency distribution, visualizations, like histograms, box plots, and bar charts, we can do for a single variable. We are analyzing about a single variable, we go with the univariate analysis. So we are going to analyze a single column variable. That means, for example, I'm having a score, I'm having 1,000 records, I'm having 10 columns. Under the 10 column, I'm having a one column called score. If I analyze only the particular score column, then What it is? It is univariate analysis. What are things I will check there? I will find there. I will find the mean value, median value, mode, variance, how the data is distributed. We will use the histograms, box plots, and bar chart for as visualization. So that it will be very clear and it will give the very clear understanding. Okay. Also, this helps understanding the distribution and central tendency of data detecting skewness. Yes, how the data is distributed. It's distributed normally or it is distributed right skewed or left skewed. How it was distributed and how it was identified. We can also identify the outliers. Some data may be exception. For example, if we take as a score, the majority of data lies from out of 100, majority of data lies from 60 to 85. Suppose for an example, only 2 data lies after 95. In 1000 data, 998 data lies between 50 and 85, but only 2 data lies above 95. Now, means that 2 data lying above 95 is an outlier. Likewise, you identify the outliers. Okay, there are many techniques for that to identify the outliers accurately. Okay, this is for a single variable. How do I analyze a single variable? Okay, now comes the two variables. How do we analyze two variables? How do we analyze the relationship between two variables? Yes, how do we analyze that? Yes, using scatter plots, correlation matrix, and cross tabulation. What is the relationship between sales and advertisement? What is the relationship between sales and cost price? What is the relationship between sales and quality? Likewise, you can do all those analysis using the tools scatter plots, correlation matrix, cross tabulation, etc. This helps in determining whether two variables are correlated. Okay, two variables are they really they have any relationship is correlated. Not correlated in the sense they are not they do not have any relationship between them. They are dependent or independent or any have any interaction. So that we can also find the trends, patterns, and causality between the variables. Then what is multivariate? If I have to find the relationship between more than two variables, I will go for multivariate analysis. I can compare and contrast and find the relationship between many variables at a time. Okay, what the tools used are bat plots, heat maps, CD scatter plots, PCA, and all. This type of analysis helps when dealing with complex data sets with many variables so that we can uncover the hidden pattern and relationships. And next comes the missing data handling. What is this missing data handling? Suppose we have a data set comprises of 1000 records. Among 1000 records, I am having 10 columns with 1000 rows. I'm having 10 columns and 1000 rows. In that one column, 75% of data has been missed or empty. How can I use the data set without doing anything to the missing data? Therefore, columns or rows having 70 more than 70% missing data. That may be not applicable data or uh, not available data. What can be done at that time? It is more than 75%. We can remove that column or a row. It is having more than 75%. But if it is less than 25%, we should take that values into account. What we are going to do is that 25% missing where there is empty values. We are going to calculate using the some imputation methods. We have having a number of imputation methods. We will be creating values based upon the existing values. Based upon the existing values in the data set, the system itself will automatically create. You'll be using coding for that, it will create automatically. That is called missing data. We should handle that. If it is more missing value, we are going to remove the column or row. If it is less missing value, we are going to create the missing value. So that should be accountable. Less missing values are accountable for the processing to get the proper output, to get the proper insights. Okay. The tools One of the first step it is check for missing data, which can significantly impact the analysis. Definitely, what are the tools? Missing value imputation, yes. When its lesser value is missing value, then we can do missing value imputation. If we have more missing values, we are going to remove the rows or columns with missing data, and visualization like missing data heat maps also can be applied to check. Identifying patterns in missing data and addressing it properly is a key for reliable research. Yes, definitely is a key for reliable research. We should not avoid that. We should handle the missing data properly. Fine. Next comes the outlier detection. What are outliers? Outliers are values that deviate significantly from other data points and can distort statistical analysis. We have seen the outliers are exceptions. See, we saw an example. Yes, for score column, if I have the 1,000 records, 998 values are from 50 to 85, but only two values are above 95. They are called outliers. Same way, we can also check the simple one. We can check those outlier values in the box plots, the scores, scatter plots, and IQR. Those outliers also should be handled. Okay, they also play a crucial for ensuring data quality and accuracy. And the last step or last key components of EDA is data transformation and feature engineering. Yes. EDA involves manipulating and transforming variables to make them suitable for modeling. We cannot take the raw data directly. We should modify it, transform it, which is standard, which is make in standard formats. What are the techniques for that? We are going to use this log transformation, scaling, or normalizing. Can make the data easier to work with in a later stages. They're going to transformation means normalizing data should be in the normalized format. Okay. And what is feature engineering? We can also create new features. That means we can create a new column value. Otherwise, we can split an existing column into multiple. Otherwise, we can remove the column. That is called feature engineering. Anyway, we can either create a column or remove a column or split the existing column into many subparts. Otherwise, data transformation is for transforming the data to a standard format through scaling or normalization. What are the common tools used for EDA? Most probably Python is used. You can also use R programming. Okay. What are the Python libraries we use for EDA? The common Python libraries are Pandas for data manipulation and summary statistics, Matplotlib and Seaborn for creating visualizations like histograms, box plot, and scatter plots, NumPy for handling numerical operations and handling large data sets. Scikit-learn offers tools for basic machine learning but also useful for pre-processing data, and Plotly for interactive visualizations. And these are the packages available in R. And at last, we are going to see the typical steps in EDA and we will conclude with that. Yes, what are the typical steps in EDA? Loading the data, yes, we will load the data set. It might be as a CSV file, comma separated value file, or SQL database file, or any other file format. We can load the data. And what is next step comes on the cleaning, the data cleaning. Yes, we should check whether the data is having missing values, duplicate entries. We should remove the duplicate entries and inconsistencies in the data set. Yes, for example, for score should have the values from 0 to 100. The minimum value of a score is 0 and the maximum value of a score is 100. Should not be less than 0 or greater than 100. That is inconsistent. The same way, it should not have a character instead of a number. Should have one numeric values from 0 to 100. That is the inconsistency. Should be in a consistent manner. Okay. And standardizing the formats, date formats. Yes, date format should have some certain format for date. Also, the categorical variables. For example, I follow a categorical for three stages. It may be a disease, um, mild, moderate, and severe. If I have three categorical variable, I should follow three categorical variable throughout the data set. I should not have different types of variables there. Should have mild, moderate, or severe. Categorical variable should be standard. Okay. And next come the descriptive statistics. First, I'm loading the data, checking the after loading only through coding only. I'm going to check whether the data set is having missing value, any other duplicate value, or any other inconsistencies in the column values. I will be checking using the coding. Next come the descriptive statistics. What is the descriptive statistics? Generate summary statistics for each value, each variable. Yes, we'll find the mean, median, modern, standard deviation, etc. After that, just we have loaded the data. After that, the loaded data is cleaned without for handling missing values, duplicate entries, and inconsistency in the data set. And then third one, we are finding the univariate analysis. That is what the summary statistics for each and every individual variable. And then we are visualizing the data. We're creating visualization to better understand distribution, understand the distributions, trends, and relationship. We are going to use histograms, box plots, bar charts, scatter plots, heat maps, etc. And then after visualizing, we will be checking the assumptions. How do you verify the assumption? Using hypothesis. Verifying the assumptions like normality, linearity, and homoscedasticity, equal variance, which are important when applying statistical models or machine learning algorithms. We are going to verify the assumptions. How do you verify the assumption? Using the testing hypothesis. Before that, we should form the hypothesis for that. Based on the observation, we should form the hypothesis about potential relationship or insights that could drive further analysis. After that, we'll go for feature engineering. Either we will create new variables or remove some variables or decompose some variables into many variables. Okay. And at last comes the final report, summarizing the findings in a clear and concise way, often including visualization to communicate insights effectively to the stakeholders. And what is the best practice of EDA? We are starting with simple. What start simple? Begin with the basic summaries and visualizations before diving deeper into the complex analysis. Just we are going to do the summary and visualization of the dataset. Next come the visualize often. Visualization help uncover patterns that raw numbers alone cannot reveal. Yes, we will be getting a pattern. We can be finding a pattern after visualization. And what is that document findings? Keep track of insights. They're going to keep track of the insights and the decisions and the assumptions made during the EDA process for transparency. We'll be getting the assumptions based upon the visualizations. And this is not a one-time process, it's a iteration process. It is not a one-time process. As you gain insights, you may revisit earlier steps for further analysis or deeper exploration. That is an iteration process. At last, we can conclude that EDA is an essential first step in any data analysis or data science project. It provides a solid understanding of the data, which is crucial for making informed decisions, cleaning data, selecting the right analysis methods, and ultimately building reliable models. Working on a small or massive data, it doesn't matter, but EDA helps turn raw data into an actionable insights. Thank you, all of you.